In this lesson, we're going to look at how to solve the questions from the Unit 1 Higher Specimen 2 paper. So let's look at question 1. A straight line has the equation 4x plus 2y take away 5 equals 0. Write down the equation of the line perpendicular to this one, which passes through the point negative 2, 3. So the first task here is to get the gradient of this line, and then to work out the perpendicular gradient. To get the gradient of this line, I need it in the form y equals mx plus c. So I need this due to a y and then an equals. So I want to take that 5 over the other side, and I also want to take this 4x over the other side. Now when you take it over the other side, the signs change. Basically you're adding 5 here, and you're taking away 4x. So that gives us this line, and then to get into form y equals mx plus c, you divide through by 2. And that's going to give us that. So we can now say that the gradient of this line up here is this value in front here, negative 2. Now the gradient of the perpendicular line to that is equal to a half, because m1 times m2 is equal to negative 1. Basically flip that over, that's like negative 2 over 1, flip it over and change the sign and you'll get a half. Now the question did ask for the equation of the line. This is not an equation, we've just worked out the gradient. So in order to work out the equation, we need to do y take b equals mx take a. I need this new gradient here, and I need that point up there. Okay, so let's write that out. We're going to do y take away b, which is 3 here, equals a half from our new gradient, and x take away negative 2. Now x take away negative 2 becomes x plus 2. Lastly, I'm going to multiply everything here by the value at the bottom of the fraction. So I'm going to times everything by 2, this, and this bit here. So that's going to give me 2y take away 6 equals x plus 2. And then I'm going to add the 6 to both sides. And the final answer is 2y equals x plus 8. Okay, moving on to question 2. ABCD is a rhombus. Diagonal BD, this one here, has equation y equals 5x take away 3. And point A has coordinates negative 3, 4. It says find the equation of the diagonal AC. Now in this question you need to understand that the diagonals of the rhombus cross each other at 90 degrees, i.e. they're perpendicular to each other. So the way to solve this is, again we're finding the equation of this, get the gradient of this line here, which you can clearly see, or should be able to see, is 5 from here. This line's in the form y equals mx plus c, so the gradient of this line is 5. We can then work out the gradient of the perpendicular line. Again, all we do with the gradient here is flip it over, so it's 5 over 1, so it becomes a fifth, and then change the sign, so it's negative. So the perpendicular gradient to this one is negative a fifth. We can now use this with this point up here to get the equation of this line. So again, we're doing y take away b, so y take away 4, there's your b, equals negative a fifth x plus 3, because it's going to be x take away negative 3. We now want to times everything by 5. So that means multiply this by 5, and this multiplier by 5. So 5y take away 20 is negative x take away 3. So negative x, and then negative 1 times 3 is negative 3. Finally, I'm going to add 20 onto each side to give my answer. Okay, question 3. A new regulation states the gradient of all ramps into a building must be less than 0.26. The diagram shows a sketch of the ramp. Does the ramp satisfy the new regulations? This table says it satisfies if m is less than or equal to 0.26. Does not satisfy if m is greater than 0.26. So if we look at the diagram, this diagram relates angles and gradients, and there's a formula we've learned in higher maths that relates angles and gradients, and it's m equals tan theta. I'll start up here. Now you saw 15 appearing. The reason that 15 appears is because the gradient is equal to the tan of the angle that traps the line and the positive direction of the x-axis, i.e. this angle here. And because we know a straight line is 180 degrees, this angle here has got to be 15 because that side's 165. So the gradient of this line is equal to the tan of 15. If you type that into your calculator, making sure it's in degrees mode, it'll come out to be 0.267. Now to finally answer the question, does it satisfy regulations? Well, no it doesn't, because it's greater than 0.26. So the ramp does not satisfy the regulations as 0.267 is greater than 0.26.